Welcome, everybody. Welcome to my talk about my journey building a dynamic provider. For the word dynamic, I'll elaborate on that quickly or later. Let's go ahead. For myself, Marco Martinez. I'm an infrastructure automation architect. I love automating infrastructure, and I work for Swisscom in the B2B department. First, let's talk about the importance of data. So what I was trying to do is there's a tool that kind of aggregates the data, and organizations usually have problems with managing their infrastructure. And those problems, usually the root of that is not having the data in a way they want it. They don't have it in a central location. They need the data to reduce errors, to accelerate their decision making, and they also don't have it available at the right time to make those decisions. So the value of data is having it, and also the value is having it in a good quality. Sometimes we have data, but it's like a big pile, and we really have to process it and aggregate it before it's worth anything. So Infrahub is a solution that has all the data. It's used in usually in the networking space, where we have IP addresses, we have like our MAC addresses, or we just generally have our network data in there. And this is called the network source of truth. So what I was trying to do is building an open Tofu provider, integrating into that network source of truth, and being able to configure that. So the conventional approach in the infrastructure space is coding everything statically into our open Tofu providers. We're putting in the IP manually. We're saying what instance is it? Is it like a T2 micro or what kind of thing is? But just imagine that we tell Infrahub, oh, give me an unused IP. Just give me any IP. I don't care about it. I don't want to put it into a TF-vars file. Or we do it the different way. We get it from the cloud provider, and we just write it back to Infrahub, and then Infrahub can do whatever they want with it. So another automation tool can grab this IP and then do its thing. Also, what would be handy is like, oh, I don't want to define my config for my vSwitch. Just Infrahub, give me my config for my vSwitch, and my Tofu provider does the thing it needs to do with it, and that's fine. So we don't need to change it always statically. We can kind of have like this dynamic approach with the government centrally in this network source of truth. It makes it more accessible. We can have a read-only variant, or we can also have it read-write. So first of all, trying to write this provider, I was doing an analysis of how could I make this the best way. So with the technical challenges is, if for everybody knowing GraphQL, we don't really have an API that is well defined. We get back whatever we ask for. So having this problem, we would just shift it to the user, would just say like, yeah, ask for the data you want, and I give it back to you with my provider. But that's not really what I wanted to do. And also, this GraphQL problematic starts one shift earlier, is because Infrahub doesn't have a schema. So you can define your own schema as you go. You have this branching mechanism where you can adjust your schema. And also, Infrahub doesn't really have a Go provider, which the Tofu providers usually are written in. Yes. So I was looking at similar problems. Who else could have this problem? But I didn't really find an adequate solution for it. Nobody really had the same problems I had, since usually the fields are very well defined. But Infrahub doesn't really have that. I neither know the fields nor I know the data. So that was kind of a rough spot to be in. So I was trying to get that fixed. So I looked at several implementation approaches. On the bottom, you can see the read-only approaches, where it was just Infrahub provides a REST API, but it's read-only, and I can only access some part of the data. So my first approach was looking at it and was like, can I use the REST provider? Just maybe you use one that somebody has already built, but didn't really work. Can I build a custom REST provider that will work for me? And yeah, not really. It doesn't really offer what it should do. Then can I use the GraphQL provider that already exists in the registry? Yes, I can, but I will just shift the whole work to the user. So the user has to input their GraphQL queries, and it kind of doesn't make sense. So I decided on option number 4 is building my own custom provider, and I kind of have to abstract this GraphQL problematic that I don't know what I want for the user. So going ahead, on the right-hand side, you can see how you define the schema in Infrahub. And on the bottom, you can see what I really want. It's like, I want to have a device. I want to have a host name. I want to have like maybe a status value, maybe a role value, depending on today. Maybe tomorrow, the host name will be named name. Maybe the status will be role. Or, well, maybe not role, because role already exists. But maybe the status will be, yeah, health check or health status. Yeah. So this analysis really kind of made it unfeasible, or resulted in not being feasible, that I have a static provider. So my GraphQL needs to be in sync with the schema. So according to that, I built an architecture. The architecture had, the goal is to build a reusable provider so everybody can use the provider, but it needs to account for the instances having different schemas. Yeah. So my takeaway is the provider needs to be generated dynamically. That's why I say dynamic provider when I talk about it. So going ahead, I still want it to be used normally. I go into the TF file, I do plan, I do apply, whatever, and it does the thing it does. Going to the implementation, where should I start? Do I build it? I just took the scaffolding repo from Terraform or from HashiCorp, suited my needs, was simple. Then I tried to model all my use cases to the life cycle, which kind of went well, and I could figure out, like, yeah, it's always kind of the same. So I built with the Go templating engine. I tried getting my schema, or getting, I had these lifecycle methods I could generate dynamically, and just put that in and generate that from the start. Everything was kind of similar to each other. Well, that brings me to the GraphQL thematic. I kind of recognized I cannot do it without a simple input from the user. So now I have like this need that the user inputs a GraphQL query, can be a very simple one, and based on that, I'll generate an abstraction layer. And then on this abstraction layer, I'll generate the provider, and that is usable like that. So the user just inputs this simple thing and gets a whole provider out of it. Of course, I validated against the schema. This GenQL Gen client kind of generates all the Go code to query this, and I can use those because those values are well known. I can put that into the provider with the templating language. Basic structure I could use for everything, so I didn't need to template that. It's just basic API keys, server address, and branching. Yeah, straightforward. Also, the nice thing of the scaffolding repository is it generates the documentation automatically, which was pretty handy if it's not the same for everybody. For the system overview, I kind of got like a little pipeline going. It's all a make file. It does it. So I feed in the GraphQL queries. I say I want the device. I have a host name. I have a value. I have like a make. And then it all takes these things, checks it against the schema of the GraphQL, generates this library that is able to query the GraphQL, generates the provider, creates a GitHub release, also creates a manifest, and pushes it into my private registry that I did for this purpose, that I can just have multiple providers with different names and different versions at the same time. And then I can use it. I can just put in the thing and do that. What is a little bit of a downside is the schema is baked into the provider, but I didn't find any other way of doing that, which brought some complexity into it. Also, since we have different schemas and also we have a branching mechanism, we cannot ensure that the schema is the same on each branch. So you will have to, as a user, do that with the name and the version. Obviously, it's not very mature yet. It still has some problems. I want to enhance the GraphQL type support because, not all types are supported yet. The state sync is obviously a big problem, as you could imagine. If you change branches or even if you change the provider, the state sometimes is not fine. I would love to get that fixed, maybe use another approach for that. I don't know. I hope somebody in the audience can help me here. Has any? Also, it would be nice to be able to migrate the state between branches. It works sometimes. Sometimes it falls into a black hole. So we'll need to see what to do that. The interaction between branches works fairly well, which is surprising, but sometimes it doesn't work. And also it would be nice to make it more dynamic, that I have this one provider and is this magic thing that does everything, but I couldn't find a way to do that. Another thing is if I cannot make it this magic unicorn, maybe AI could help me generate queries, because if I feed in the whole GraphQL schema, it gets too big. Maybe AI is the solution. Maybe it's also the answer, we don't know. And it would be nice if I could just on the fly define what I need, but I don't think it's very realistic, to be honest. Conclusion is there's very good documentation to build a provider. I was surprised. It's my first provider. It's not perfect, obviously, as everybody can see. It can be difficult to map functions to your use cases, or I had this problem at least. Maybe my use case wasn't also the intended way to use OpenTofu. My design choices brought a lot of complexity into it with the need to generate it for yourself. And the official provider would have a lower barrier to entry for users, because right now, if you need to generate it yourself, the user will probably panic. But this is all the work I've done. If somebody wants to check it out, feel free to do it. And I would like to open it for questions, if there are any.
Thank you, Marco. You mentioned that you still have a roadmap and there's still some issues, et cetera. Are you using this in production? Do you intend to use it in production soon? How are you thinking about that?
Currently, I'm not using it in production. It's still proof of concept, but maybe further down the line, I would like to do that. It still has a few big issues open, but I think it could get there. And if anybody's interested, I would be happy to share.
So you said you're using Terraform provider framework?
Yeah.
So it's a bit more raw, but have you considered using Terraform provider Go?
I considered it, but since it was in the scope of my master thesis, it was a little bit too heavy.
Yeah, it's quite a bit more raw. But I think if you could build a provider that embedded the URL, the query itself, but it could on startup fetch the schema and then fill out the fields it needs to within there. But I definitely understand it's a whole nother vertical wall of a learning curve jumping from one project to the other. But if you have any questions, feel free to reach out on Slack to us on that.
Thanks, I appreciate it. Yeah, well, the biggest problem I saw is if you don't know what you want, how could you ever define it in code, right? So I didn't want to shift too much to the user, so the user needs to do everything. So that was kind of the balance I tried to walk. So the user still has to do something, but he also gets something for his work. Yeah.
All right. Thank you very much, Marco.